Hello everybody, we are working on Chapter 2 in our JavaScript text tonight, and we're going to be learning a lot of real important concepts. I know that we talked about a few of these concepts in brief last week, and we're going to be clarifying them a little bit more this week. And my concern always is for those that have not had a formal programming class yet. In fact, can I get a show of hands? Who has not had Intro to Programming yet? Have you had any programming before? Okay. All right. Well, welcome to programming. The ideal is, I always hope that, if you can be full-time, that you're taking this at the same time you're doing Intro to Programming, and by the time we get to JavaScript, you already kind of understand variables and all these types of things. But since this is kind of like an introduction for you to programming, you'll see many of these topics will repeat language to language. Every language has variables, every language has functions or methods, every language has arrays, that type of thing. So repetition is a good thing, and JavaScript is actually not a bad language to learn your first programming with because it's very forgiving. It's not true of a lot of languages, though. All right, here are the objectives for this chapter. So we're going to look at functions, we're going to look at expressions and operators, and then we're going to look at order of precedence in terms of working with expressions. Now, I know that you guys have already heard me say this, but when you take code in JavaScript and you start bundling it together, so instead of creating an individual series of steps, you start creating groups of instructions, and then you combine those together and you give them a name, and those typically are called functions in JavaScript. In other languages, we call them methods or functions interchangeably. If you're learning Visual Basic, you'll also learn sub-procedures, and there's functions and subroutines and things like that. Functionally, they're all basically the same. It's just little nuances that are different in each language. I always also say that if you hear me say method, I probably mean function, and if I say function, I might mean method, but they're kind of the same thing. So just so I kind of exist in many different languages in my head, so sometimes I confuse my words. And it's not really confusion, it's just what they're known by. But notice that the difference, there actually is a distinct difference between what we call a function and a method. And the method is associated with what we call an object. We haven't really formally learned object-oriented programming yet. When you start taking your Java class in this program, that's when you're going to learn object-oriented programming. But suffice it to say that an object is kind of like an encapsulated item that is based upon a pattern, and then that object has capabilities that are called methods. And it's usually little blocks of code that are functions that are written inside the object that you can just call by name. So you'll see how that works when you start doing object-oriented programming, but the technical definition of a method is that it is a separate set of operations that's named within an object. Now, JavaScript itself, because it's not formally an object-oriented language, we kind of trick it into being one. The things that we block together in JavaScript and name we call functions. And you'll see that the keyword function has to be present in order to make it a function. Okay. Now, the way you actually create a function, well, you say function, and you'll see it on the next slide here, and then you give it a name. And then after you give it a name, you have a set of parentheses, and it's really kind of the parentheses that denotes the fact that it is a function or a method. That's one of the identifiers. We also have the capability of creating functions that do not have a name. I'm not sure if the author really demonstrates that in this chapter, but when you get to some higher levels of coding, what you're going to see is sometimes you just force code to run. It's in a block, but we don't give it a name because we don't need to call it. It just runs right in position. But what we're going to learn initially is giving things a name, and that's really generally a better practice. But there is a place for anonymous functions as well. Now, one of the real advantages of creating functions is the fact that once you create a set of operations and you give it a name, you then have the capability of calling it as many times as you want. So let's just take a look at how they're doing the definition here. So you see in that second bullet, they're using that keyword function, and then they're showing in blue what should be, the name of the function generically. And then inside the parentheses are what we call parameters. Parameters can be pieces of information that we're sending to the function that the function's going to use to do its operation. So those are some real critical things. Also notice that we have curly brackets that start and end a function that kind of like isolates it so we know where it begins and ends. And then you can have any number of a series of statements inside the function. There's really no limit to the amount that you can put in there as far as I know. But usually it's a series of statements that are grouped together. If you do run an anonymous function, you'll see the only difference is there's no name. So the thought is always, well, why would you ever do that? Believe it or not, there's reasons to do it. For example, I can take whatever a function does and set it, the output of it equivalent to a variable. So one approach might be, let's say I have a variable called, taxes. And that equals a series of statements that calculates taxes. It just so happens we're not giving it a name. It just sits on the other side of the equal sign and it just runs. I know that's a little bit of a conceptual leap initially. When you see it in action, I think you'll understand a little bit better. What you see here within that third little bullet there is what you can expect when you take a function and you call upon it. So you've already created it like you have here, and there's a series of statements that perform an action. But then when you're somewhere else in your code and you want to use that, you have to call it by name, pass whatever parameters it expects, right? So it might not expect any, or it might expect a list. But notice that in this case, if you are passing things in, you separate them with commas. So somewhere, and you can kind of figure this out, right? A function that calculates volume needs length, width, and height to figure out volume, right? So somewhere else you're defining those, and then what do you suppose happens inside calculate volume? Length times width times height, right? That's how you calculate it. And then you also return a value, which we'll see shortly. But this is how you call it. You use the name, you send in parameters, if any, and it executes. You jump out of the sequence of where your code is currently, jumps to the function, it executes, and brings you back. All right? All right, so notice there's a couple of things that they're going to try to push you towards, and I know I kind of like skip around topic-wise. I really don't necessarily rehearse with the PowerPoint. I just look at the topics and go. And what you'll see is that the statements within the function, it says do the actual work, and I already told you starting and ending curly brackets, that those are the boundaries. But they're also suggesting that you put your JavaScript in an external file, the same way you do your CSS. That's really considered best practice. It does not mean that you can't put it in line with your code or in the head section. You absolutely can, and there's times when it's a good practice and times when it's not. But generally speaking, it is suggested that you put it in an external file. It's just easier to manage. The other advantage to that, of course, is that many different pages can share the same file, so you don't have to replicate your code over and over again. It's just more efficient. All right, so you see, here's kind of like an extrapolation of that calculate volume function, where we have it declared with the name function, we give it the name, we have the parameters that are being passed in, curly brackets, and then inside here we set a new variable called volume. We do the math with the stuff that's being sent in, and then we do a document write to output to the screen. Okay. How do you call a function? I think I already explained that one. You just call it by name. But you have to have those parentheses following it. And if it's expecting to receive something, you have to send that something to it. That one thing I always find interesting, a function, when it's receiving values, those are called parameters from the perspective of the function. But from the perspective of the spot you're sending it from, they're called arguments. If that confuses you, because I'll tell you what, it confused me for a good decade or so before I finally latched onto it, just say you're just passing values. Same difference. All right. So I don't think I actually test you on arguments versus parameters, but you'll see those two words often interchangeably used, and often people use them incorrectly. All right, I think that's pretty clear. All right, so a couple different ways, or several different ways you can call functions. So take a look at this. We looked at some forms earlier chapters, earlier weeks, where you had like input buttons. Notice you had an on-click event handler, and when that button is clicked, it triggers this function. You know it's a function because it's got a name and it's got parentheses after it. Notice there's nothing in between in this case. Another approach is that you can actually take an object and attach an event handler to it in a different way. And this is kind of what's weird about JavaScript. There's sometimes like 20 different ways to do the same thing, and none of them are wrong. And what's going to dictate which one you use is either whatever you remember, whatever's simpler, or whatever the situation dictates. Because you might have like chosen a certain path to execute things, and then you're kind of stuck on that path, so you continue with that path. But if you think about the fact that an on-click event handler doesn't necessarily have to be attached to an input type, you can actually attach it to anything. So it could be a paragraph that gets the on-click and triggers the action. And then in that case, notice how it triggers the function. That's kind of odd. It's not one of my favorite ways to do it, frankly, but that's how they do it. Another approach is to add a standard event listener, and then as part of an event listener, you can see that event listener's got parentheses after it. That tells you right there that add event listener is a function that expects 3 parameters, one of which, the middle one, is the function you're going to execute when you do the clicking. Isn't that interesting? So 3 different approaches. I think that probably the simplest and most straight-ahead way to do it is to basically use just the name of the function and the parentheses. They talk a little bit here about Internet Explorer 8. I can say we can summarily dismiss it unless you're forced into a situation where you're working with legacy stuff. And hopefully that's not the case in your career, but sometimes that is the case. And then in that case, you'll probably figure it out on your own. And you'll understand why you'll probably write code really quick that says use a better browser. I mean, even Microsoft is now saying goodbye, Internet Explorer. So that's kind of a hint. Now, folks, we did an examination last week where we were looking at some web pages. I'm trying to get my browser up on the screen here. And where we were using the inspect element tools and then the little console tool that's part of it. You guys saw how I did that: right click, inspect, and then console. And then any JavaScript errors that you're going to generate are going to end up here. Believe it or not, you can actually execute code from this spot too. A lot of people don't know that. But you can write little snippets of JavaScript and test it right here. It's kind of a scary thing in a sense, but really what it's doing is it's giving you an example of how JavaScript works without actually having to write the program. So if you wanted to test a little theory about some code, you can have at it right there. On all the different browsers, they show you the way that you can invoke that console mode using keyboard shortcuts. Generally speaking, right-click, inspect. I think on Edge, and I just happen to have it here in my toolbar. It does have inspect element now. Because otherwise what you typically find is that you'll have developer tools, and I think it's consistent across most browsers that you use F12 as the developer tools button. One thing that's really weird for anybody that runs on a Mac, if you use Safari, Safari does not natively show you those tools. They don't even show you view source. It's kind of, unless they've changed it recently. So you actually have to go into the settings for Safari, and there's a little checkbox somewhere that says enable developer options or something like that, and then you get all those tools available to you. Very much for that reason, a lot of developers don't really use Safari as, which is terrible to say because it's a primary browser on Apple platforms, to do their development work. They'll typically use Chrome or Firefox. But it's important to note that Safari does have the same engine behind it that Chrome does. They run off the same base code. Different skin, same code. That's important to know. Now, whether they diverge in the future, I really don't know. All right, here's an example of what the console looks like in a couple of different browsers. And I'll let you explore that on your own. You know, we always forget to talk about the Opera browser. Does anybody run that browser? Yeah, Opera is not a bad browser. If you haven't tried it, you should check it out. I'm not sure that I have it loaded on this machine. Apparently I don't. But if you are curious, you know, we can just take a real brief moment here to kind of jet out to the internet and take a look. See, Opera web browser. Yeah, go to opera.com. It's actually not a bad browser. If you have never tried it, I would encourage you to at least play with it a couple of times. I would also encourage you to play with Safari, but unfortunately, I think Apple has completely stopped development of Safari for Windows. They used to offer it for Windows. So at this point, if you want to play with Safari, you either have to have like an iPhone, iPad, or a Mac. If anybody wants a demonstration, I can always remote to my home machine and show you how it works if you're curious. It's kind of fun to do sometimes. But I'll tell you what, if you are a developer and you're putting your stuff out into the world, you kind of need to either have access to a Mac or own a Mac. Not as your primary machine, but just to see the results of what you're doing. There's pieces of software that will emulate all the different devices and operating systems, but you can't really trust those as much as you trust an actual machine that's running it. So if you have that mindset of I hate Macs or Mac people, I hate PCs, you really kind of have to delve into both worlds in this field. You have to be kind of independent of all that. But Opera is a cool browser. If you haven't tried it, it actually is one of the browsers that came up with a lot of the little cool things that are in browsers now, like tabs. Inspect element came from there, I believe, and a couple of other tools that we kind of take for granted that weren't always part of browsers. Opera's always been kind of on the cutting edge that way. Now, one other thing you can do with functions is you can also add what they call a return statement. And basically what that means is wherever the function was called from, you can send a value back to it. So one example would be, let's say I have something that I'm doing a little snippet of code, and maybe what I'll do is I'll actually type right inside the slide here. Somewhere in the main body of my code, I might have a variable, and I call it average, and then I just set that equal to and that would be my statement. So functionally what that does is I've set up a variable, and remember with variables, the way they work, and there should not be a capital V. The way variables work with one single equal sign is that whatever is on the right side of that equal sign is what's going to be placed into the left side of the equal sign. So we don't have any real tangible value here, but what this does is it calls the function, it sends 3 numbers to it, so they would all travel down here in corresponding positions. So 1 goes into A, 2 goes into B, 3 goes into C, and then we do the math, so we're going to add ABC. That's going to get stored in sum of numbers, and then sum of numbers divided by 3 will get stored in result, and then we return result. So what happens is we'll return the value. What's the number that's going to go back? 2, right? That should be instant math for you guys, I hope. 1 plus 2 plus 3 divided by 3. So 6 divided by 3 is 2. Okay. Sometimes I feel compelled to do the math because I assume people know it, but I can't always assume. But it's going to return that 2 back to where it was called from, which is this spot. So this, in essence, will turn into the number 2 and then get stored in average. See how that works? So the return statement, if you're going to use that with a function, when it comes back, it has to have a place to go. So whenever you see a function that's got a return and it's being called from somewhere else, it almost always will be set to a variable or be used in additional calculations. All right, I should probably remove that from the slide, unless the author gives me royalties. All right, another important concept is where the variable that we're working with has scope. All right, scope basically refers to when we have a variable that's named, where can we use that variable and call it? If a variable is declared inside of a function, that's the only place we can use it. Okay? If we declare the variable outside of all the functions, any of the functions can use it. You see the difference? But you got to be careful because any of the functions can also change it. So those are like little things you have to watch for. So scope is really what we consider where that variable is valid. Okay? So if it's inside of a function, only within the function. If it's outside of the function, any part of the program can use it. If it's outside of all the functions, we call it a global. If it's inside of a function, we call it local. Okay? These are terms you'll get to know real well as you learn your programming. Now, notice it says here that good programming technique suggests that you always use the var keyword. And I don't know if he really mentioned it here at all. All right, so here, okay, so he does. I'm glad he does. It says here, if you want something to be local, in other words, to make sure that it only exists inside that function, you should use the var keyword. Remember, JavaScript isn't all that picky, but it can also lead you down a path to destruction, too, as a result, if you're not careful. So if you want it, good practice is to always use var. Practicality is a lot of programmers don't. When they start to use it is when things aren't working the way they thought they would work. And then they use it to make it work the way they thought it would work. I mean, that's the reality of it. So, all right, so check out this one. It says, poor programming technique, declaring a global variable inside of a function by not using the var keyword, which makes it very hard to identify them. Very hard. Now, one thing that a lot of times programmers will do with things that are global is they'll sometimes use certain naming conventions to help them identify it. And JavaScript as a language technically doesn't have a construct called a constant, which is a variable that can't change. And one of the conventions there is that you use all capital letters. So think carefully about how you name things, because that can really help quite a bit. This one I think is important enough to probably read verbatim. It says, if variable declared, should it be if a variable? Okay, now I'm doing grammar. I'll just read it as is. If variable declared within a function and does not include the var keyword, it automatically becomes a global. Are you guys catching that? So inside of a function, it doesn't say var, then any part of the program can access it. That's the part that throws people for a loop. All right, so this is even trickier now. It says a program may contain global and local variables with the same name. Very bad practice, but it can happen. And in some cases, people choose to do that on purpose. You might not conceive as to why right now, but that's not really the issue. You know, my suggestion always is to have unique names for all your variables, global and local, so you just don't even run the risk of stepping on the toes of something else. There's no question then. Right, here's a little bit of an example of variable scope. Notice we have a function, and inside the function we have a variable called color, which equals purple. So when we write the color, the value that's printed is purple because this is local to where that statement is. They're within the same scope. If this was not present here, it would print green. Okay? Now the interesting thing here is notice what happens with this little snippet of code. Basically, you have the function. Functions do not run by themselves. If I did not have this statement present, nothing would happen with that function. I declare the function, and then I have to call it by name to make it execute. So really what's going to come to the screen now is this line of code will run. It goes to the function, does what it does, which is prints purple, and then it goes to the next statement, and it prints green. Because green is outside of the function and is basically on the same level of the program as these other two statements are. So in terms of this particular statement, the document write, it's in the same scope with color set to green. Now you know how you master the knowledge of this? By doing it a whole bunch of times, messing it up, getting it right, messing it up, getting it right, and then you get it. So I don't expect it to immediately stick if you've never done programming before. That's okay, because you will see it in action and then it will all become crystal clear. Now JavaScript, as with many other languages, in fact all languages I can think of, have built-in functions. There's functions that are built in that allow you to do certain things, and we've seen a number of them already. I mean, even on the preceding slide, we didn't write a function called write, did we? Where did that come from? Well, it's built into JavaScript. Notice that it's got parentheses after it, and we send in a value, so it's expecting a value. What are we writing? Well, we're going to write color. Okay, what's color? Green. And they give you a little bit of an example of these. I'm not going to read through what they are. This is just a very simple little example of some of the things that are available. And now we're going to switch our attention over to data types. Now we did allude to these last week a little bit, if you recall. But data types basically tell a programming language what type of information you're utilizing at any given point in time. JavaScript happens to be one of those languages that doesn't really care too much about data types in terms of formal declaration. If you switch to a language like Java, which you guys are all going to learn, it cares very much about the data type. I can't take a decimal number and place it into an integer. An integer is a counting number. A decimal number obviously has a decimal in it. Can't do it. Here in JavaScript, it doesn't really matter. decimal, integer, negative, positive, whatever. You don't even have to say it's a number, you just do it. That's the other thing. In a formal language, you have to say integer, give it a name, and then give it a value. In JavaScript, you just come up with a variable name and put whatever value you want right into it. There's also a data type of Boolean. Boolean basically stands for true, false, and depending on the language, you'll typically use keywords like true and false. In some cases, you can use 1 and 0. But basically, that's what we use to determine the state of something, typically to be able to execute an operation. If whatever is true, then do this. That's an example. Of course, strings are basically snippets of text that are encapsulated usually with double or single quotes. The interesting thing is you can put numbers in as text. So you can put double quotes around the number, but then what happens is you can't do math with it. Okay. There's also these other two types. Undefined means that nothing has been, assigned yet, or there's no value given to it. And then there's null, which is the absence of anything. And even though those sound like they're the same, they are different. Technologically, they're very different in computer memory, so they get different values. So every once in a while, if you write code that's got a logic error in it, you might say value is undefined, or cannot be null, or something like that, and you'll know then to set values. But these data types here are what we call primitive data types that JavaScript can work with. Super flexible. You move to other programming languages, you're going to find that they have like a dozen different data types. Like 9 of them will be for numbers. And depending on the kind of math you're doing, one might be more relevant than the other. All right, so talking a little bit more about data types here. It says the null value is weird, right? Because it's telling you it's a data type and a value all wrapped into one, and it says can be assigned to a variable, but it indicates no usable value. So why do you do that? That third bullet is why. So you can make sure it doesn't have a value. So there's certain circumstances where you write code, and I actually had to write a little bit of JavaScript code for my Java 2 class last week, that in order to get one of the objects to work correctly, we had to initialize it to null. So in other words, we wrote a little bit of code that said result set equals null, as opposed to just saying result set, which is undefined. And then we were getting an error when it was undefined saying null pointer error. And we're like, well, how do we fix? It said it's a null. Okay. And then it fixed. So there's a little bit of a difference in terms of how the computer memory is handled. Because if you give a value of null, it's a value. If it's undefined, there's nothing. Okay, so it's kind of like a box that you name, but you can't put anything into it. Somebody sealed it. All right, so I think that helps hopefully clarify between those two different types there. All right, take a little bit of a look at how this works. So in this very first line of code here, you see that they declare the variable state tax. They don't give it a value. It creates the box and gives it a name, right? If you output what it is, it comes out with undefined because you didn't put anything in there. If you give it a value of 40, then it's 40, right, obviously. But if you set it to null, it has a value of null. There's something in the box. It just happens to be null. My joke was always, nothing is something. So if you think of it that way, because if it wasn't something, how could you define it and call it nothing? Unassigned is the absence of it. So, all right, let's not get into philosophy here. All right, so I think that we've talked about these topics enough. Most formal programming languages are strongly typed. Java, C++, languages like that. You have to have the data types. You have to know what they are. You have to know how they work. JavaScript falls into the second category, and there's other modern languages that do as well, but JavaScript is probably the most notable one and arguably the most important. That's pretty loose. In fact, I can declare a variable and switch data types on the fly. That's kind of handy to know as well. So notice here that JavaScript, it says, automatically determines the data type on its own. With numbers, believe it or not, it's actually kind of a nice thing. Because it's like, should I use decimal? Should I use double? Should I use integer? Should I use float? Should I use short int? That's what you start asking yourself when you're doing a traditional language. But it just figures it out. Not only that, notice that you can also set it to be Boolean, to be null, or a string using all the same name. All of those are perfectly valid. So you can do that in Java code, JavaScript code. You could have it be worth a number one statement, switch over to text the next statement. It's not recommended, but you can totally do it. It doesn't matter. All right, so when we talk about data types, I think we've already talked about integers, right? Counting numbers, floating point numbers. It's got a decimal point in it. I'm not sure what else to say aside from that. We know what the true false are, right? In JavaScript, we use the words true and false. And if optionally, in some cases, you can use 1 and 0, and it operates kind of in the same capacity. I think the safer approach is to use the words true and false, though. You start to analyze some of the logic that goes behind this, and you'll see, for example, here, new customer equals true, contractor rates equals false. So here, when we say write new customer plus new customer equals true, and then you get your output. You see how that works? I think it's pretty straight ahead. Strings are just basically a series of characters. We encapsulate those in quotes, double or single. Doesn't matter which you use as long as you are consistent. The reason that both are allowed is so that you can nest different quoted statements inside of other quoted statements. You guys probably learned that in English class, right? Because I can have a quote of somebody quoting somebody else. President Barack Obama said, I quote John F. Kennedy. So the quote inside has a different set of quotes. Usually, we go double on the outside and single on the inside, but you can reverse them. It doesn't really matter, just so as long as you're consistent. You can also set some variables to be empty strings. So instead of saying null, you just put double quotes, opening and closing with nothing in between. And that's a common technique for clearing a string variable. And I tend to like that better than doing null, personally. All right, I think we talked about that enough. I have a little example here. So I have document write, speech at the Berlin Wall, excerpt. Okay. 2,000 years ago, the proudest boast was civis Romanus sum. Did anybody know it? Did anybody ever take Latin? Nobody does that anymore, right? It's actually a good language to know because it teaches you a lot about other languages. A lot of languages come from it. All right, so the thing to look at is the way that the quotes are used. That's really the point. So here we have document writing this statement of HTML. And inside that, or that is sitting inside a set of double quotes, and inside that set of double quotes, we have an additional quote that says civis Romanus sum. Notice those are single quotes. if I would happen to put a double quote in this spot here, the statement would end there and the rest of it would not print. See how that works? That's why it needs to be present. In this case, we're reversing it. We're starting with single quotes on the outside and double quotes on the inside. That's fine. It's just the converse as long as you're consistent. All right. And then here, they're just showing you that you can output it all. Not a big deal. Another thing that you'll learn about if you're fresh to programming is a thing we call concatenation. And concatenation is basically a way that we add strings together. So we might have a few different strings stored in variables and we can stitch them together, or we might have a variable, which is a string. See, the plus sign is the concatenation operator, so we're going to take Honolulu, add it to is in, and notice that there's a space before is and after in, because those are characters too. A space is a character. And then we're adding it to location. So the output of this then becomes Honolulu is in Hawaii. Okay, and those are concatenated together. That's what that means. Another thing that you can do, and we haven't really talked much about this operator yet, is not only can you take a value and assign it to a variable, but you can also concatenate using what we call a compound assignment operator. And that's kind of a weird thing to use initially, but basically what it allows us to do is take what's already in the variable and add to it the other thing while keeping the thing that you had in there already there. Now, if you happen to use numbers, and I should probably go back to that. If you happen to use numbers in a statement like this, for example, if I just put the number 5 here in place of destination, it would kind of confuse things. Because as a straight up number, it's not a string. It'll try to do math. But if I take the number, let's say the number 5, and put double quotes around it, then it becomes a character and we can add it to a string. Okay? Another little tool that we have at our disposal is the thing that we call an escape character. An escape character always begins with a backslash, and its purpose is basically to allow us to create characters that we couldn't otherwise add to a string. It's kind of a weird concept until you see it in action. But some things that we do with escape sequences is, what if I want to put a backslash inside of a series? Well, that's probably not the best one to start with. But okay, here's a good one. How about I'm using a real complicated set of single and double quotes, but somewhere inside of a set of single quotes, I want to have an apostrophe on the word don't, right? The only way that I can get that in there without breaking the code is to use the escape backslash in a single quote. And then it reads it as an apostrophe as opposed to a single quote. I know, a little confusing initially. The other thing that we use escape characters for most commonly, I'm showing you the ones that are most used are probably single and double quote and new line. And what new line does is it allows you to create like a whole string of characters, and you don't want to just keep going across the screen, so you do a /n, and then after the n, it drops down the line on the screen. So that's kind of a handy one. It is. All right. This slide here shows our math operators. We've talked about these briefly as well. And this slide actually is a lot more complete than the simplistic version we looked at last time. So I'm going to actually zoom in a little bit and talk about these. Now, the ones that we're most typically used to when we think about, operators, we think of math, right? Plus, minus, divide, multiply. And I think most of you are aware that multiplication is the asterisk and division is the forward slash. But we have these other ones that are kind of weird. And that is this one, modulus. What the heck is modulus? Well, basically modulus is what we call remainder division. So instead of looking for the exact answer, we are looking for the remainder. So if I did 3 mod 2, what's the remainder? 1. How many times does 2 go into 3? How much is left over? Okay. So the answer to it is 1. And then the question you always get is, what good is that? Why would you ever use modulus? Do you want to know a great example for modulus? Making change. Something you do in your head, you don't even think about it, right? That costs 57 cents, and I gave you $1. How much change are you giving back to me? 42 cents. All right, well, the problem is you got quarters, nickels, dimes, and pennies. Right, so you got 42. How many times does 25 go into 42? Think about that. Once, right? So you got 1 quarter, but then you got how much left over? 23, right? Well, 25 can't go into 23, so, 42 mod 25 is 23. So now I got a new number to work with, 23, so we go to the next increment down, which is a dime. How many times does a dime go into 23? Twice. So we got a quarter and 2 dimes? No, that's not right. Well, you get the idea, right? And then you do the mod, and then you come up with a remainder again, and then you divide with the next lowest increment. But that's, somebody had to like mathematically figure that out. It's like, how are we going to make change, right? Well, if we come up with this math operator that just works off of the remainder, it helps to solve a whole lot of problems. So that's why it exists. Another real important set of operators are the increment and the decrement. Like you guys have probably heard of the programming language C++. One of the reasons it's called C++ is because it's one of the first languages that had that operator available. So basically what that allows you to do, if you have a number or a variable, and I say num equals 1, and then in my next statement I say num plus plus, num has now become 2. Because it's very common in programming that you keep count of things or you count down from things. So that gives us a mechanism for doing it. The other thing that we have is what we call negation, and that is basically to allow for the inverse of whatever a value is. I don't see it very commonly used in this fashion, but if we have an example, I'll show you. What I see more often is what we see down here, which is not equal. All right, so we have the assignment operator. That's when we, take whatever's on the right and assign it to whatever's on the left. So we call it an assignment operator. It's not technically an equals sign. If we want to do equals in programming, we do equal equal. Not to confuse things, but that's how we do it. You guys, I think, already saw how plus equals work, but there's also minus equals. And, really good examples of something like that. And here I'm going to bring up my text editor here, so I can just do an example. So if I'm writing a little bit of code and I say var sum equals 1, so sum equals 1, and then I say sum equals sum plus 1, so what does sum equal? 2. Then what does sum equal if I go plus equals 1? What's it valued at now? 3. Right? Here it's worth, here it's worth 1. Here it's worth 2. And here it's worth 3. So really what we're saying is this statement here is functionally equivalent to this statement. So we're taking the value and adding something to it. Well, if we're taking the value and adding something to it, we can just do it like this. The same is true for the minus equals, times equals, divide equals. They all work in the same fashion. For most functional purposes, I don't see people often using anything aside from plus equals or minus equals because it tends to get confusing. But you absolutely can do that. It just takes a little bit of planning. Obviously, you can use plus equals with strings, but that's the only one you can use with strings. All the rest are really intended for use with numbers only. All right, and yeah, you can do it with modulus too. You want to like mess up your brain cells a little bit? Try that one. And it won't be on the final, I promise. All right, then we go back to all our comparison operators here. We got the less than, the greater than or equal to, etc. And those are really important when we start testing logic. The ones that might throw you a little bit are the fact that we use two equal sign to indicate that something is equivalent. But that is to test the truth of it, not to set a value. So if I say 4 = 5, false. It is not equal to 5. If I said 4 = 4, true. Right? Because they're the same. The other thing that we have that's interesting is what we call strict equivalency. And JavaScript's kind of a weird language for that, because what that really is implying is that I could have a situation that would be maybe like this. Maybe I have a variable called num1 that's equal to 4. And then I have a different variable called num2 that's equal to 4. One's a string, one's a number. Now, if I just do this, if I say num1 equal num2, JavaScript will return true. You ready for that? JavaScript will do that. If I put in equal, it then becomes false because one is a string and one is a number. That concept transfers to other languages, except when the data typing is strict, an integer can't equal a double, for example. And you'll see how that works when you get there someday. The other one that's interesting too is whenever you see the exclamation point in front of an equal sign, that indicates not equal. Okay? All right, we spent a bit of time on that slide, that's for sure, but that's okay. All right, we also have some additional types of operators, and I suppose I should say zoomed in for this. And some of these are used for certain types of situations. The logical ones at the top are when we're doing testing of the validity of certain types of statements, and we're testing to see if this is true and that is true. So we use ampersand, ampersand. Or we're checking to see if a condition is true or the other condition is true. We'll get into this in more detail. I don't want to kind of blow the future work that's coming down the line here. Or we check to see if things are not equivalent by just saying exclamation. And once again, this is to test truth. And usually when you're testing to see if something is true or false, that's to see if you're going to execute a statement or not. You already saw the concatenation operator in effect. So when we apply it to strings, the plus sign concatenates. When we do the compound concatenation, it looks just like the math one, except it's doing it with strings. Then we have a bunch of these special ones, and these you'll also get to learn as we go along. And you'll see that some of them are characters or collections of characters, and some of them are actually entire words, but really they're still considered operators. So property access, a good example of that is when we saw like document.write. That's an example of that. When we learn about arrays in the next chapter, you'll see that arrays are often denoted in just about every language except for VB by using square brackets. VB uses parentheses. Function calls will always have curly brackets and parentheses. Commas are used as separators, etc. These other ones you'll get to learn in special situations, and I don't anticipate we'll find any of those quite yet. All right, we also have these like weird ones. These are also ones that we're probably not going to be seeing anytime soon, but there's ones that are called binary and unary operators. And notice it says it requires an operand before and after the operator. So in other words, we have 2 plus 2. So we need both of them. We need something on either side to do the addition. We can't just say plus 2. It doesn't work. So that's why they're called binary. Unary basically refers to the fact that we don't need that. So when we do a plus equals, that's an example of that. Or when we do a plus plus or a minus minus, that's an example of that as well. The other way that you can use it is when you use that exclamation point. So for example, if I had a variable and I said true, which is a Boolean, and then I put an exclamation in front of it, it's not true, that's an operator. Which you could also just say is false, but in some circumstances, you see the logic. A lot of it is really based on logic. All right, so I know that the author here is going to go into talking about how all of these operate, and I think that we've kind of already done this. So that's why I'm just going through these slides very quickly. If there's a pertinent example, we can take a look at it. All right, so here's an example of division. How many times does 16 or 6 go into 15? Twice. 2.5, right? Well, it tells you down here. But if I do 15 mod 6, it goes in there twice with 3 left over, so the remainder is 3. All right. This is the one thing I was telling you about, how JavaScript attempts to convert string values to numbers. So if you did 4 plus 2 in quotes, it would convert that to a number and then come up with 6. Most languages do not do that. Just want you to know that. We talked about the prefix and postfix. And the thing that's kind of interesting about the plus plus and the minus minus, you can put it either at the front of a variable name or at the end of a variable name. There are differences in how it handles memory, but basically, functionally, they give you the same value. All right, they give you a little example here. I'll let you guys work through that on your own. We talked about the assignment operator. I think we talked about all of these enough that I can just kind of very quickly go through them. I hope you're okay with that, because I know you guys can read and I don't want to belabor it. And what I do suggest, if you really want to get how it works, is step through the slides here and try the little examples. All right, so comparison operators, once again, we do these things so that we can figure out whether or not we're going to execute a block of code typically. And we talked about all these. There is one special operator type statement, and you'll see here as we're getting into what we call conditional statements. Why do we have true-false statements? Why do we have conditional operators? Because very often we're going to say, if your income is over $100,000, then we're going to hammer you with taxes, right? Right? If only, right? So they have that expression that goes in there. But they've also come up with this modern expression that we will talk about, where instead of saying if then, they use question mark and colon. Once again, we're going to take a look at that separately. The real importance of this is one of the basic structures of programming, and I guess I kind of feel compelled to do like an intro to programming stuff here, is programming basically happens in patterns. Somebody not that long ago, believe it or not, like 40, 50 years ago, figured out that programming really is broken down into, I think, 3 or 4 basic types of operations. One is sequential steps. Do this, do that, do this, do that, right? And then once in a while you get into the situation, like I just explained, if you make X amount of money, then we're going to charge this amount of tax. If you don't make hardly any money, then you don't get any tax. But I can't do that in a sequence. We get to a point where we have to make a decision. So decisions are based on conditions. So when you hear conditional statements, if, else, that kind of thing, it's called decisions. So we have sequential steps, we have decisions. The other thing that we see is repetition. So sometimes in order to get a task done, right, if I'm going to mow the lawn, I walk one way across the lawn with the mower, I get to the other end, I turn around and come back the other way. I just keep going back and forth and back and forth and back and forth, progressing a little bit each time until I get the whole lawn done, right? So in terms of programming, that's a very common thing that happens too. So for example, if I wrote a program that read through a list of names and then output them to the screen, it would be silly to write 100 lines of code to output 100 names. So we have structures called loops that just have one line of code that does that and just keeps going until it's done. So we have sequence, we have decision or selection, some people will call it, and then we have repetition. Those are like the 3 main programming logic steps. And the thing I find interesting about that is people figured this stuff out before they were even computer languages to figure it out with. They were just doing it all with pencil and paper, trying to figure out problems. So why would you create an instruction set that's unnecessarily, detailed when you can just say, repeat this over and over again until you're done? Or don't do this unless this condition is true, or if this condition is true, do that. Okay? We're getting real close to the end here, and I want to finish this up before we take our break. I know you guys are looking at the clock, so I feel for you. All right, so here what they're demonstrating to us is basically a modern approach for doing if-else statements. And what I'm going to do is I'm actually going to copy this code and bring it into my text editor so I can show you what they're pushing as the modern approach and what the old approach would be for the same thing. So I'm going to copy the code twice. And in this top example, I'm going to give you the old school approach. So I would actually have a statement that says if, then we put in a condition. If int variable is greater than 100, then we will execute this step. And typically what you'll do with an if statement is you will use curly brackets, and you will do something like this. So this is the true side of the statement. And if that did not happen to be the case, then we have what we call an else. It's got its own set of curly brackets, and we would do something like this. So given a certain condition, we'll check this variable to see if it is indeed greater than 100. If it is greater than 100, then we execute this statement, the first statement. Please ignore the box and the colon. It should be like that. Okay, so if this statement is not true, then we execute the else part of the statement, which is a different result. What has happened in the recent past is somebody came up with this more modern way to do it, and I'm not always a fan of teaching this first, so it kind of actually concerns me a little bit that the book does it, that they use, in place of the statements we see above, they use the question mark and the colon. So really what the statement is saying is, if this is true, do what's after the question mark. Otherwise, do what's after the colon. Now this is frankly only effective if there's only one statement in each side of the condition. You can't do multiple statements. If you have multiple statements, you're stuck using this approach. You know, I'm kind of old school. I try to use this modern approach when it's a really simple little statement. And a lot of languages now are including this approach. So I just want you to be aware of it. I mean, the book is intelligently showing you the modern approach, which I think is good, but you got to be careful of it. All right, so this is great. Falsy and truthy values. How do you like that? So if you have values for variables that are set in any of these 6 little listings here, so empty quotes, -0, which really can't be done, 0, null, or undefined, what do you suppose nan is, aside from bread? Not a number is what it stands for. So all of those would be treated as false in a true-false statement. Otherwise, everything else is true. Okay, once again, we have our logical operators, because sometimes when we're checking to see if something is true or false, sometimes we'll have multiple conditions. So for example, if I have another variable here called, I don't know, ASDF, I might say something if int variable is greater than 100 and ASDF is less than 50, the AND requires that both of those statements are true. So the first part is true, the second part is not. So the whole statement evaluates to false, because AND implies this has to be true and that has to be true. So in this case, we would execute this side of the equation. An OR, which is the 2 pipes, that's what they're called, only requires that one statement is true. So if one of them is true, the whole thing evaluates to true and then executes. The other logical operator is a not. So for example, I could say something like, oops, not equal 50. False, right? Okay, just to give you an idea. Then we have all these special operators. These are the ones that we talked about. And I'm just kind of skipping over them for right now. There is an order of precedence to both mathematical and logical operators. I know that you guys probably in school learned the rule of PEMDA. Did you guys ever learn that? Which stands for what? Parens, exponents, multiply, divide, yeah. Right. So it's the order in which the operations happen. So when you have a mathematical equation and it's stated in this fashion, 30 divided by 5 times 2, does it matter if I multiply times 2 first or divide by 5 first? In this case, what's 30 divided by 5? 6. 6 times 2? 12. What's 5 times 2? Okay, what's 30 divided by... Yeah, it does matter. So if you are trying to coerce a particular mathematical outcome, you need to know the order of operations. So what would this evaluate to? Well, according to our little chart, divide is less important than multiply. So the multiplication would happen first, so the answer is 3. If you're unsure, you put parentheses around things, because it'll do whatever's inside the parentheses first, and then do the other operations. So if you weren't sure, I would just put parentheses around the 5 and the 2, then you know for sure. Remember, most of the time when you're doing this kind of stuff, it will usually be with variables as opposed to numbers necessarily. All right, so when you're doing order of operations and you start throwing us all these strange little operators, it works from associativity of right to left, right being the far right side, working back towards the assignment operator. So it'll do the plus plus first, then it'll do the times equal, and then the equal, which isn't really an equal, it's an assignment. So the example is x is 3, so if I do a plus plus x, it's 4. And then if I multiply equals it to y, it's 4 times 2. That's what it's telling you, right? So then what's x? Eight. That is correct. It's funny because he doesn't give you the answer. All right, folks, we're going to call that a chapter. These are the things that we've learned, hopefully. And when we come back, we're going to dig into the practice exercises in the chapter. All right? So take yourself a good long break.